Hello. If you want to get a job at a big tech company, you need strong data structures and algorithm skills. But knowing DSA alone isn't enough. You also need to clearly structure your thoughts and communicate your reasoning to the interviewer. That's why in this video, I'll run a mock interview based on the LeetCode Valid Palindrome problem. This problem is a perfect way to demonstrate your ability to optimize string processing from offline space down to constant, while handling complex character filtering logic. This way, you'll not only understand the problem and its solution, but also learn how to explain it confidently during an interview. Let's get started. Hi there, thanks for joining us today. We'll start with the coding task. Are you ready?
Hello, yes, I'm ready.
Great. The problem is saying that you are given a string and you need to return true if it is a palindrome and false otherwise. A palindrome is a phrase that reads the same forward and backward, but you also need to convert all uppercase letters into lowercase letters and remove all non-alphanumeric characters.
Let me restate the problem to ensure I'm on the right track. I need to determine if a string is a palindrome, but I must ignore case and skip any characters that isn't a letter or a digit.
Exactly.
A few questions regarding the constraints. How should we handle an empty string?
An empty string reads the same forward and backward, so we consider it a valid palindrome.
Understood. And what is the maximum length of the string?
The length can be up to 2 times 10 to the 5th characters.
Okay, with 200,000 characters, a naive approach that involves heavy string concatenation might be inefficient. Another question, are we only concerned with standard ASCII characters?
Yeah, focus on standard alphanumeric ASCII.
The most naive approach would be to create a new string by filtering out the non-alphanumeric characters and converting everything to lowercase. And we can use regex or is alphanumeric function in Python. And then we can just compare our first string to its reverse. This is a very Pythonic approach and readable, but it uses often extra space and to store the new strings.
Right, can we do this without the extra space?
Yes, to achieve all of one space, I can use a two-pointer approach. I'll place one pointer at the start and one at the end of the string, and then I will move them toward the center, but also I'll add logic to skip any character that isn't alphanumeric. We can create while loop inside and check if it's alphanumeric and move our pointer to the next position. And also I'll compare the characters at these pointers. So here right pointer equals to left pointer, so we're moving on. Then we see non-alphanumeric character where we're incrementing left pointer, go on, compare them, and when we get different characters at the pointers, we just return false. And this way, we only traverse the string once, and it gives us O(n) time complexity, and we don't allocate any major extra memory. Yeah, but we get O(n) or O(n) divided by 2, which is O(n) still in terms of Vigo.
That sounds like a plan. Let's see the code.
Okay, first I have to create a function. Let's call it isPalindrome, and it takes string and returns Boolean. After that, I'll normalize the string to handle the case sensitivity requirement, s equals s lower. After that, we can initialize two pointers, left and right. Right will be the length of s minus 1. After that, we should create a loop, and the loop will move on while L less or equals to the right pointer, and inside of it, first of all, we must increment the left pointer and decrement the right pointer to handle infinite loop error. So right now here we should compare our values, our characters at their position, and if they're not equal, we just drop false. That's right. And at the end of the loop, somewhere here, we should return true if it's okay. Now I'm considering all the characters and I don't eliminate non-alphanumeric characters, so we also have to handle that. And to handle that, we can just create another loop and check if our value is alphanumeric. We can use this Python function. And if it's not, so if it's not alphanumeric, we increment our left pointer by 1, and another loop will be the same, but here we compare right pointer the same way. Something like this, and I see an error here. We also have to check if L less than R, because we can just have problems with such case where we have only empty space, so, or something like this without characters, I'm saying. And also we have to compare here if L less than R as well, or we can change it to R more than L, just to be just to make it more readable. So once both pointers are unvalid characters, I compare them, and if they are different, it's not a palindrome. Otherwise, I continue moving forward. Now I want to trace this with the string. As an example, I can create a string like A and with exclamation mark and something like this. So our pure string will be ABA. And let me just trace this. First, the string becomes ABA like this, and then I'm starting a loop, and left pointer character is A and right pointer character is also A, and they both are alphanumeric. So, oh, I forgot here to add end. So yeah, and we're moving on because they both are alphanumeric and they equal. So we just increment our left pointer and decrement right pointer, and now our characters are exclamation mark and B, and here the character by left pointer is non-alphanumeric, so we increment left pointer, and then it becomes empty space, and we check it again. If empty space is alphanumeric, and it's not. So we increment left pointer again. We have B, and our right pointer is also on B. So we just skip this part here and skip this part because they equals B. So we increment our pointers, and our loop is no longer uh, moving on. So we return true after that.
Good job. Another question. What if the input was so large that it didn't fit in memory? Say it's being streamed over a network.
Good question. If the input is a stream, we can't use length of s and lower function on the string. So if the stream allows us to read from both ends, we could still use 2 pointers. But if it's a standard one-way stream, I think it's good to use a stack. We would push the first half of the alphanumeric characters onto a stack and then compare them with the second half. And this would cost us orphan space, but it's the only way to check a palindrome in a single pass without random access.
Makes sense. Great job today.
Thank you. I enjoyed the challenge.